Funny thing, microphones work better when I turn them on. All right, folks, if we could have your attention for our next speaker coming up. We are going to be talking about Kubernetes and the security associated with it. Please welcome to the stage Haydn Johnson.
Thank you very much for having me. So this headset is like the matrix that comes out the back here and hangs out. So we'll see how I go and can focus. Good talk by Fernandez, or Fernando, always get it wrong, on explaining containers and everything to you. So I don't have to do that. So a quarter of my talk I can just scratch. How are you guys doing? Enjoying BSides? Yep. Cool. Good to hear. I'm going to try and stay enthusiastic because I've had some coffee and it's all jittering and everything. We'll see what happens. So I normally make a joke that if you're not here for Kubernetes, you're in the wrong talk and should jump to the other track. But the good thing today is there's no other track. So if you're not here for my talk, too bad, sort of thing. So let's see. It's not going to work, huh? Cool. It worked like just before. And I don't even know how to get to that screen now. Aha. Will that work? Yeah, that'll do. My talk notes aren't there, but she'll be right. So before we get to the good stuff, obviously you want to know who I am so that I have some credibility and you're like, yes, this guy sort of knows what he's talking about. My name's Haydn Johnson. You can contact me on Twitter at my original Twitter name, at Haydn Johnson, my name. I pull that joke at different conferences, get different reactions. Total dead silence is a new one. Like, really raring to go here, guys. I've got my OSCP and GXPN, so I've got a little pen testing history. 5 years in the industry, 1 year in Australia at Deloitte, the Big Four. A couple of years here in Calgary, and now I'm in Toronto. So on Twitter, there was this discussion about presenting and not referencing people and taking credit for other people's work. So I just had this big slide to answer that. They're really good talks. Like, if you want to learn Kubernetes in a proper way and not rushed in 25 minutes, you should go and see those. Some motivation on why you want to see this talk is because with Kubernetes, it's becoming the future. Red teamers and attackers are all over it, because as we know with technology, it's secured out the box. And yeah, I've been learning it for my org. Your org may be going to it, and let's have some fun. Now, I didn't want to say it's growing huge and have you just trust me. I did some Googling, like 2 seconds, and found a couple of Medium posts on Kubernetes, containers, things like that, on the popularity. And with GitHub, as you can see, this nice blue line on this faded screen, oh, my laser light does work, awesome. It jumps up quite high. So from 2014 to 2017, Kubernetes is quite popular on GitHub. Now, this can be hard without slides. So here we are to the talk. Kubernetes, security, you need to know about it. I should probably slow down. Here I'm rushing. So what we're going to cover today is not an in-depth look at Kubernetes and containers, because it is just 25 minutes. We're going to go through what happens at a company before Kubernetes, or Docker, things like that. What is Kubernetes? Here I am forgetting my own talk. The benefits and importance of Kubernetes and containers, but primarily Kubernetes, and the security principles to help. But before that, I'd like to show some basic hacks that have happened that maybe or may not know of. Things like that. So who here works at a tech company with coding apps and things like that? Yep. Wow, actually a lot of you. That's awesome. Everyone's got jobs. Yay. So as you probably know, or you might know these terms, a company that creates applications or code has to test it, has to make sure it's bug-free, things of that nature. So these terms, such as continuous integration, continuous deployment, and development, all these different methodologies were created. So when you type into Google continuous, they generally come up straight away. So this is that term you hear with ops, DevOps, DevSecOps, and everything. It's just how they develop code, the tech apps, and keep the infrastructure up. So this little one I wanted to show because there's continuous delivery and continuous deployment. Now, continuous delivery is where you write the code, and then you think it's running, so you hand it off to QA or the production to manually test, like Fernandez was saying. But they test it manually. The continuous deployment is that it's all done automatically. So when you write your code, it runs, it goes through the test. Yes, security passed on automation, good job. Yes, it passed the functionality. Yes, processing worked. It's not gonna break anything. Then it goes into production, which is great. But you can imagine how many security holes that are tested by scanners, right? So companies in the tech industry have many moving parts, as I said, and they need to be able to produce code, applications. So then DevOps, SecOps, Agile, etc., all these things were created. Now, for those visual learners, I wanted to create some pictures because it's easier this way to explain. So developers and coders have lots to do, lots of milestones, Scrum, Kanban board, sprints. Man, being at my new place is like opened my eyes to why security isn't in the state it is. Anyhow, they all create automation, continuous integration to help, and that's fantastic. You get your products to market sooner, you make more money, you make your investors happy. However, as we all know with technology, that is not secured very well. Now, the idea of continuous integration, the cloud, virtual machines, is to get everything created faster. So what if developers, as Fernando said, could code without worrying about the underlying infrastructure or how the environment variables are set up? Now, this is where containers come into play. So this is when containers were born. Containers are abstracted from the operating system. So it can be a web server or anything else. And like you have your little box and you say, for my web server, I want the libraries, the environments, the variables. So I can probably skip this because it was done in the previous talk. But the idea is that it's a nice little box and it's not a full virtual machine. So for the visual learners again, you have your host or your ESXi server, and virtual machines are another complete operating system. So you have Windows A, B, C, sitting on a Windows server or something like that. Now, containers here, you have your host operating system, but the containers all use the same plumbing and infrastructure of the host. So the libraries for the web app are contained together. So you'll have web app A and C, which are separate, but not complete virtual machines. Now, I was talking to a mentor of mine on Twitter, and she's like, have you heard this analogy? I was like, what analogy? Of houses and apartments? I was like, oh, must be pretty good. So the idea is that a house has its own plumbing, its own bathtub, things like that, or infrastructure, has its own concrete foundation. An apartment or a condo, which I live in, it's like small contained environments where you live, all sharing the same infrastructure. Does that make sense? Like house containers are abstracted, and then Kubernetes is abstraction even more. So what do containers help with? They just help the developers code without having to worry about the baseline environment. So it helps speed up development, speeds up troubleshooting, things like that, and it all gets automated in today's day. So now we've had a little bit of a history lesson on DevOps, ITOps, things like that. The real talk is on Kubernetes. So what is Kubernetes? I've only got like 10, 20 minutes, if that, really to go through it, or 5 minutes, I guess, with other stuff I want to show. So how does one simplify this? At work, I was going through, because we're deploying Kubernetes, and they're like, hey, security manager, security dude, what should we be concerned about? And I was like, WTF, bro, I don't even know Kubernetes yet. So I had to run through, build it on my home server to get an idea, do the Googling, and then this talk came out of it. So if you go to the Kubernetes website, they will say Kubernetes is a portable, extensible, open source platform for managing blah, 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 blah. And it's really professional, but you don't understand that. So Kubernetes is basically a container platform, like a management console. The way I think about it is like Active Directory for containers, that you can centrally manage everything. So the way Kubernetes is broken up so that you don't have to think low level is that there's a deployment aspect to Kubernetes and Docker. So that the deployment is setting up an image, downloading and installing it, that's good. Now, services allow you on your local machine to access it internally, so that it's all local. So you have to, and then ingress is your external traffic. So how does your customers or how does the cloud get to your container? You add ingress. So you would say, with ignoring syntax and code, deploy this image, let me access it internally and make it accessible on port 8080, which is also known as a node port for external traffic. So this just helps you to sort of visualize how Kubernetes then abstracts everything. But what does Kubernetes actually look like? So as I said, with the service, you've got the internal traffic. So say you have your laptop or your server, it's called a node. This is hard because you guys don't have the underlying infrastructure, so we're going to jump back and forwards. But each node, your laptop, can host a pod. What's a pod, you may ask, Haydn? A pod can contain one or more containers. So I put the little image of Docker to remind you that Docker is a container, and then a pod controls everything that happens in that container. Again, Kubernetes is an abstraction on an abstraction. So Kubernetes helps you control this pod while not worrying about the intricate details. And like I said, a pod can have 1, 2, 3, or multiple containers. So it's quite simple, not really. But the main idea is when I try to say in 25 minutes, how do I teach people Kubernetes and get you excited to learn about it? I have to shorten and simplify. So to simplify it, there's a master node, which I think of as the brain, and the control panel, or Active Directory, like your domain controller. You have these systems, there's configurations you can push out, great. So you have your brain, and it can control different pods. That's fantastic. So with Kubernetes, you can either have containers run on like your local system. Kubernetes can also, as a brain stuff up or without swearing, it can also be a virtual machine. So on my ESXi server, I actually experimented with creating a kube master. That's the original name, but the master controls the 2 slaves, and then it pushes out, maintains it all that way. But it can also be just on your local machine, your different pods. So you have your front end, you have the boot camp, which is a tutorial, like virtual machines, but a lot lighter and abstracted again even more, your containers. So it's really good that way. So we understand Kubernetes controls containers and allows you to do all these cool things without having to look at the actual lower level, networking and actually coding the ports open example. So what are the benefits of Kubernetes? So when you go to Google it, benefits of Kubernetes, it came up with infrastructure lock-in and things like that. But what that actually means, again, is your developers don't have to worry about the operating system. So it's all fancy wording. But the great thing with Kubernetes is the scalability, the health checks, and what's the third one? Less downtime. Now, what that looks like is that the health checks, automatic. You know IT ops, if you've ever worked in there, a system goes down, you're like, oh, crap, I've got this alarm going off, got to reboot it, tell everyone, pull it back up. Takes forever, or maintenance. What happens is, say you have 3 pods of web application A, and one of them goes down, this little red circle. It has a health check with Kubernetes that it'll say, okay, one of your pods is down, so there's 2. It's meant to be 3, so we're going to bring it back up online, which is really good. It helps with the reliability of applications, load balancing, things like that. Now, upgrades are great as well, because at work with the operations team, we have maintenance windows for Windows or production on Linux servers, upgrading patches with Puppet and things like that. And we have to tell our partners our maintenance window is going to be 6 hours. Please, we're not going to be making money for that time. Let's just hold on. So here you have your like version A, I called it. Version A of your pod or your server. You want to upgrade it to version B. So instead of having to take them all down all at once, Kubernetes says, oh, you want to upgrade from V1 to V2, let's do that logically or systematically. So it'll take one down, it'll put it back up, upgrade it to version B, and then all three are running. Then it will take another one down and pop the second version up. So it systematically helps you upgrade that way, which I think is really cool. And with businesses and agile development these days, it's quite necessary and critical. So we've gone through, wow, I got through this fast. So we've gone through containers, Kubernetes, and why Kubernetes is really important. Okay, so my thing was security. We really need to know about this because the things I'm learning are pretty scary. And then I was like, how do I express to you guys why it's necessary? But you already know technology, when it's new, goes so well. Like, you just Google the Amazon hacks, the EC2 instances, Google Cloud, Internet of Things. How many of those have default passwords and have been hacked and Mirai botnet and everything? So I just threw up some screenshots. It's quite amazing that every time we get new technology and it's going to save money, everyone's on board. But for securing it, no. So this is where we come into play. But the thing with new technology, I didn't want to just say we all know it gets hacked because you don't know me, you don't trust me. So I Googled a bit and I found kernel ownage, Chris Gates. He's done purple teaming and this DevOps talks around the country in America, I think. I don't know if he's done it here yet. But the idea is that all the technology we use, such as Puppet, Amazon Cloud, and Amazon Credentials, things like that, to help speed up development, there's obviously gaps in what we do. So as hackers or attackers, we will use what's native, like Windows PowerShell, and figure our way out in through the cloud or, The idea is that it's not tuned properly and it'll get hacked. I did make my font bigger. That's why it's hanging off the butt of the bottom of the slide. So that does get much worse. I'll try to fix it. So before containers, we sort of went to virtual machines and like, yay, virtual machines, it's totally secure because it's a whole operating system on another operating system. I gave away my secret. So you've got your virtual machine. Nobody can get to the hypervisor, but yet with the technology and the attackers these days, or over the years, there are hypervisor escapes. There's all these exploits to get to them. So the reason why security needs to know about Kubernetes, because of the excitement and the growth, is because Kubernetes is no different. There's default configurations, default passwords. There's functionality within Kubernetes that's quite powerful for the low-level users. So the first topic I wanted to cover was default configuration. So I'm just going to take a minute if you guys want to read this. So the key line, if you are wondering, is they're treated as anonymous requests and give a username of system anonymous. So if this HTTPS endpoint is not blocked or controlled by the firewall or a firewall rule to stop traffic, or it's not flagged as do not allow, you can execute commands as system. Pretty cool, huh? So on this Medium blog post, they're like, my Kubernetes machine was running crypto mining software, but my admin console has a password. There's been no password hacks. There's no, what's going on here? And then because of the previous post, they were able to find out that there was a curl command that actually executed because the HTTPS endpoint was not flagged as do not allow. Now, with new technology, it's great to get it out there as quick as possible, but there's no one securing it. And even myself, if I deployed Kubernetes, I wouldn't be like, oh, I don't need to deny anonymous access. Like, that should be 101. It's like a FTP server with anonymous access. Like, why? So this other one, again, is not the HTTPS endpoint, but there was an administrative console open on AWS. So from that, they just logged into the web admin console, the Kubernetes version, and found a pod, and then started crypto mining, like nice and simple. It's a rerun of the Mongo databases that are up on the cloud. It's a rerun of everything that goes up in the cloud and just is exposed everywhere. So Tesla, Elon Musk shoots cars into space, creates flamethrowers, but doesn't hire people to add passwords to their consoles. So this one was just an insecure Kubernetes console. So it didn't have a login name or a password, or probably default. But someone on the cloud went, hey, cool, I found this one. But the thing was, one of their Kubernetes pods had access to the Amazon S3 credentials and telemetry that way. So not only could they access Kubernetes pod, they could then get into Amazon. So again, with all this technology, it's exploding and creating interconnections that we just have no idea how to control. This is not from Tesla, but it's an example of Kubernetes with some S3 credentials in it. Like that's how easy it was. It was so APT. Some simple, more advanced Kubernetes attacks is that there's this great YouTube video on hacking and hiding Kubernetes, but it's all about using the environment. So you can install custom tools. If you execute a command, you can reach out to the API and say, hi, Kubernetes API or master, please give me a list of each pod, its name, and everything like that. It's just like, here you go. And you don't need much access. So it's just like Active Directory. Like, it's so hard to configure. And the new versions are getting much better. Yeah, you can read metrics. Might be able to install other services inside the cluster. So Kubernetes really needs your help, or at least needs security help. So some security principles, again, for everything is basically be aware that security matters. The internet is a dangerous place because every time you put something up, it's going to be attacked with default credentials or a script that brute forces it. So don't use password. Again, the Center for Internet Security benchmarks is really good, but you've got to make it contextual to your business and deployment and everything. So with containers, there's image scanning. So like Active Directory or your work laptops, you just have a gold image, you know it's secure, it's hardened, you use the same image again. You don't just go up, download, or git clone someone's image from like random hacker, not hacker, and deploy it in your production. So it's all about sanitization and being safe about it. And then runtime security. So each container should be like specific to one application or one reason for it existing. And so you should be running it, monitoring and logging what it does when it's up. So if it's a web app server, is it meant to LS? Is it meant to say, who am I? Is it meant to create its own GET request to some random mining company or something? No. So there's this tool called Systog Falco, which has great tutorials to bring you awareness on what you should be logging and monitoring. It's really good. So I suggest doing that and just locking it down. Hopefully, you've enjoyed my 23 minute, 25 minutes run of Kubernetes. Thank you very much for having me. And any questions? Yep, sorry. They were not Google Kubernetes engine instances, no. They were yeah. However, the Tesla one and that are actually hosted in Amazon, but not GKE, because the Google Kubernetes engine abstracts it again and adds a lot of safety and control over it. So you really have to be a ID 10T, whatever the saying is, idiot to really stuff it up that way. I was going to say... The medium one, this one was actually a Handy employee, but it wasn't at Handy, it was like local. So yeah. Anything else? Cool, thank you.
Thank you. All right, before anybody goes away, oh, one sec. Be sure to sign that. Haydn, be sure to sign that. All right, before anybody goes away, we have an opportunity to raise money for CAMH. So the idea here is, this is something that we do every year, and thankfully we have been very lucky to have the folks at Sector share this with us. We have 2 passes to give away for Sector, one for this calendar year, one for next calendar year. And the whole idea is it's a bidding process and it's an open forum type idea. Last year we went up to, what, almost $1,000? So that is a really good cause, especially when, we've all been touched by folks that have been affected by mental health issues, so I think this is actually a really good cause. So where should we start the bidding, Max? $250, all right. So for the pass for this calendar year for Sector, which starts on Monday, we're gonna start the bidding at $250. Do I hear $250? Wow, last year we had to fight them off with a stick here. Anybody, Bueller, anybody wanna go to Sector? Okay, let's put it this way, who's going to Sector? Okay, so you guys don't need tickets. Who needs a ticket? All right, we got one guy there. Oh, Terminator, nice. All right, so Kevin, what do you want to bid? All right, anyone have a bid for $250? Do I hit a hand? Ah, we got one for $250. Excellent. All right, so we've got the ball rolling. Let's try it. $300. Anybody for $300? We got a $300 over here. $350. $350 right there. This is more like it. $350, $400. $400, anyone? Bueller? Come on, this is for a good cause. Ah, there we go, $400. $400, do I hear $450? $450 in the back row, all right. $500, do I hear $500? We're at $450 right now. Do I have a $500 for this year's Sector conference? All for a good cause. $500, there we go. All right, $500, do I hear $550? We're at $500. Good cause, great conference. I might be biased. I've been working on it for 11 years. But what's the list price? Actually, you know what? That is an incredibly excellent question. I don't know. Is that 14? Oh my God. Okay, we're up to $1,400 now as list price. Thank you. Heaven forbid I would actually mention that part. All right. So at last cause we were at, was it 500? Yeah, we're at 500 right now for a $1,400 ticket. So do I hear 550? But there we go. All right, we got a 550. 550. Do I hear 600? 600. Wow, awesome. Okay, now we're getting some momentum here. 600. Do I hear 650? 650. Bueller, is that a hand up in the back row there? Yes, you with the lanyard. No? Okay. He looks incredibly alarmed, yes. All right, so 650. Anyone for 650? Oh, we got a 650. All right, 650. Do I hear 700? And yes, I'm doing $50 increments because I don't math. All right, so this is where my brain locks up and my jet lag kicks in. Where are we at right now, 650? 200? All right, 650. All right, just for that, we added 200. No, 650. All right, so we are at 650. And do we have any takers at 650, or we're going to go at 600? Going once at 600. Going twice at 600. Sold to the gentleman right there. Well done. Great cause. So if you could make sure afterwards you give your information to this gentleman here in the front row, he'll be able to sort you out. All right, now, we get to do it all again. All right, this is for next year's Sector, not this year. This is for next year's iteration. All right, so let's try this. Remember, $1,400, which I should have mentioned in the first place. Thanks again. $1,400 ticket, probably going to be more next year because Brian's funny that way. So we're going to start things off at $250. Do I have a bid of $250? We got $250. All right, $300? $300, do I have math apparently? $350. $350, oh, we got a whole bunch of $350s. $400. $450. $500. Damn. $550. $600. $600. Oh, we got a $600. $650. There we go. 700. Ooh, 750. The plot thickens. 800. Oh, right, 850. All for a good cause, 850. Do I hear an 850? You want to go to lunch, I want to hear an 850. All right, we got an 850, 900. Oh, 900, awesome. 950. 950, going once, going twice. Sold to the gentleman in the back row. Thank you very much. Give him a round of applause. Don't worry, I'll let you go in just a sec. Do we have a representative from Proofpoint in the house? Awesome. Proofpoint is our sponsor for lunch today, and give them a chance to say a couple of words.
Thank you. My name is Navincha Ramnath. I'm a principal sales engineer with Proofpoint. We do have a table outside the lecture hall. I do encourage you to come say hi. I'm very proud that our company would associate itself with this wonderful event, and I look forward to coming back next year. Thank you.
Thank you very much. All right. All right, lunch is downstairs. One key point, at 1:20 is our next speaker. You do not want to miss that one. 1:20, see you after lunch.